Hi guys, hope you all are doing good. So in our previous videos we have learned creation, traversal, insertion at beginning, insertion at end, deletion and searching. So in this today's lecture we will learn one of the most important linked list topics, that is insertion at any position. So insertion at any position. So let us understand it step by step. So without any delay, let's begin our today's lecture. Suppose we have linked list. Suppose let me write 10, 20, 40 and null. So this is our linked list. So now we want to insert 30 at position 3. So after insertion, the linked list should become 10, 20. So third position, it's gonna be 30, 40, and null value. So this is our final linked list. So how can we do it actually? So let us learn. So think about a line of students. Suppose we have a lines of student. So student 1, student 2, and student 3. So these are three students. So now a new student wants to stand between, I mean, a new student wants to stand between a student 2 and student 3. So the new student cannot simply jump in, right? So first, a space must be created between student 2 and student 3. So then connection must be adjacent. So this is exactly, so let me make, so student 1, student 2, new student and student 3. So in the same way, linked list work exactly. So linked list work exactly in the same way. So first step. So what is the first step? So first we are creating a node. Suppose we are creating node. So on the first step we are creating node. Struct node start new node. So we are creating new node. So we are allocating dynamic memory. So new node. So new node equal to struct node start. So we are allocating malloc using malloc function with size of struct node. So we have created the new node. So this is our step one. So on the step two, we are need to store data. So we need to store data. Suppose let new node be, so in our previous example we have 30, right? So new node data equal to 30. So this is, so on the next step we need to move the nodes before the insertion position. If insertion position is 3, we need to stop at position 2. So the current linked list is, suppose the current linked list is 10, 20, 40 and the null value. So this is our current linked list. So stop at node 20. So we need to stop at the 20. So we need to use a temporary pointer. So for that we are going to create a temporary pointer. For that we need to create struct node with temp. So initially temp equal to head. So this is our temp value. So now we need to move the nodes. So for that we need to use a loop. So we are using for loop. For that we need to use for loop. Initially int I equal to 1, not 0. Linked list starts from the 1. In the array means it's gonna start from 0. So in the linked list I equal to 1. So I is less than the position. So position is 3, right? So position I is incremented. So I'm sorry, I is position is, we need to write position minus 1 here, sorry. So position minus 1. So after that we need to move the temporary variable. So that for that we need to write temp equal to temp of next. So this is the for loop for to move the variables, to move the nodes. So after the loop, the temp points to the node 20. After loop, temp points to the node 20. Temp equal to, it becomes 20. So now the current situation, let me explain. So current situation. So initially temp is 10. So temp is 10. So let me write it somewhat bigger. So our current linked list is 10, 20, 40, null value. So this is a current linked list. So initially temp is pointing to the 10. So temp equal head. Now head is 10 value. So now we want the final linked list 10, 20, 30, 40 and null value. So this is our required linked list. So we want this linked list. So in the third step we need to connect new node to the next node. For that we need to write, so let me write, we need to write new node next equal to temp of next, temp of next. So this connects new node to the next node. So now the linked list will become like, so now it becomes 30, 40, so null. So it will become like this. So in the step 4, we need to connect current node to the new node. So for that we need to write temp next equal to new node. So now what will become the linked list? So now it gonna becomes 10, 20, 30, 40 and a null value. So insertion has completed. So we are successful insert the 30 at the third position. So this is all about the insertion at any position. So the two important lines are, so the two important lines. So let me write the two important lines. So let me highlight with star. So the first important line is new node. So let me write with another color. So it will be very useful. So the first important line is new node. So new node next, new node next equal to temp next. So this is our first important line. So on the second important line is temp next. So temp next equal to new node. So temp next equal to new node. So this is here actually small n, not capital N. So new node. So this is the two important lines. So we need to remember these lines carefully. So they are frequently asked in many interviews also. So let us dry run it. So let me explain in the dry run. Suppose we are, let me change the color. Suppose, so our initial linked list is 10, 20, 40 and a null value. So this is our initial linked list. So we need to insert position third, we need to insert 30, I mean new value. So new value is 30, we need to insert at position 3. So for that we need to create a node. So we need to create node that becomes 30 equal to null initially. So then we are going to execute. So we are using new node next equal to temp of next. For that it becomes 30 is to 40. So like that, 30 is to 40. Let me write here. So it becomes 30 is to 40 and equal to null. So it gonna becomes like this. So we're going to execute. Finally we are using the second important line, temp of next equal to new node. So then it gonna becomes final linked list 10, 20, 30, 40 and a null value. So we are done with the final linked list. So let us see the C code for this insertion at any position linked list. So I have all written the C code for you. So let me explain it line by line. So these two header files are very important. This can't be neglected. So these two are very important. So on the next line we have struct node. So we have created node with data and struct of next. So now we come to the main function. We have created hash head, second, third and new node. So we have allocated dynamic memory for these three nodes. So we have given some values. So we have stored data 10, 20, 40. So we have declared int position equal to 3. So we have allocated dynamic memory for new node also using malloc function. So new node data equal to 30. So struct node is, so we are using a temporary variable temp equal to head. So we are used a for loop here. So for loop here. So here is a for loop. So so we are get int I is equal to 1. So here also I have written it is position minus 1. So here, so I is less than position minus 1. So this is the cut. So position minus 1. So temp equal to temp of next. So this loop continues until I is less than position minus 1. So now these are our two important lines. So these are our two important lines. So this one and this one. So new node next equal to temp of next equal to new node. So finally temp equal to head. So now we are printing the all, using this while loop we are printing all elements, all nodes in the linked list. So %ld temp of data. So the output will be 10, 20, 30, 40. So this is all about the C code of insertion at any position in linked list. So let me ask some questions. Why do we stop at the previous node? So why do we need to stop at the previous node? So because we need access to the both sides of the linked list, so both sides of the insertion point, so at the both nodes we need access. So what are the two important pointers update? So these are the two important pointers. New node of next equal to temp of next. So temp of next equal to new node. So what is the time complexity? So next question, what is the time complexity? So in the time complexity we have, so while loop, so it gonna print so in the insertion at any position, at the worst case it will be, when it gonna insert at the last position, it gonna becomes big of n. So the time complexity will become, so the time complexity is big of n. So the big of n is the time complexity for insertion at any position, because we may need to traverse several nodes, so that's why. So what happens if the position is invalid? So the program should check boundaries before insertion. So in the real world applications, validation is important. So if the position is not well, we can simply print here position is invalid. So this is all about the insertion at any position of linked list. So let us revise quickly. So first we need to create a new node. So we need to move to the previous position, connect new node to the next node, connect previous node to the new node. So the insertion is successfully completed. So I hope this lecture is clear to everyone. If you have any doubts, you can ask in the comment section. So thanks for watching and see you guys in the next lecture.